Hello everyone, my name is Miss Ellis, and today we will be learning how to practice recalling math facts, decoding word problems, and converting units to solve equations. So what I am presenting today is a lecture that I would present in front of an entire class. However, I will discuss individually how I will accommodate for Sarah's lack of phonemic awareness as we go through the presentation. So as you can see, we will be discussing how to recall math facts, as this is something that Sarah struggles in due to her lack of phonemic awareness. We will learn how to decode word problems, specifically by reading word problems 3 times to uncover specific information, such as key information and what we are looking towards solving for, as well as just understanding the context of the problem. Sarah will learn how to convert between units. This entire unit, we will be focusing on conversions between the imperial system as well as the metric system. However, today we're going to focus solely on the imperial system, as this is what we utilize mostly within the United States. Also in this unit, we will be learning about money, how to count money, how to write out money in proper money notation. This is something we will not be covering today in this lesson. However, this is something that will be covered through this unit. And then tying it all together by being able to write an equation and solve an equation. So let's go ahead and delve into it. Our objectives. So this is something that I would have written on the whiteboard. This is something that I like to update every day. However, being that I don't have a whiteboard available to me over the summer, I decided to just provide it here on the slides for us. So these objectives pertain toward the unit as a whole, but I'll go ahead and describe the objectives to you. So again, the first one is that students can recall math facts at a speed that matches their grade level. So this is something that I would not work on excessively for the entire class. However, I believe that it is a great warm-up, and it really benefits students like Sarah who, again, lack phonemic awareness. The second objective is students can read and decode a word problem for its context and important information, then formulate a plan on how to evaluate the solution. So again, we are solving word problems, and specifically how to decode those word problems for specific information so we can write an equation and solve them. Then finally, students can solve problems involving measurement and conversion of measurements from a larger unit to a smaller unit. And again, today we are focusing on the conversion between the imperial system, specifically between feet and inches. So let's go ahead and dive into it. To begin the class, I would start with a warm-up that pertains toward mathematical facts. I believe this is a great and fun activity to encourage students to move around the classroom and answer questions. Specifically, I enjoy practicing mathematical facts through the game Around the World. So students would stand in a circle where there's 2 circles, an outer circle and an inner circle, and students can test each other on mathematical facts. Being that Sarah is shy, I would probably work with her one-on-one while the other students work together on Around the World, so I can ensure that she is getting adequate practice on her mathematical facts as a good warm-up before we delve into the higher level skills such as solving equations. All right, so to help Sarah specifically and other students who may have phonemic or may lack phonemic awareness, and just in general to help students understand the meaning of length, I'm going to go ahead and have students physically measure items within the classroom so that way they become more comfortable with the different conversions in length, specifically with the imperial system and inches, feet, and yards. So if you look at my presentation, you will see that I have provided a visual that clearly shows a yardstick and the separation between inches, the little marks on the yardstick, as well as feet. And on this visual, we can clearly see that 12 inches is 1 foot, 24 inches is 2 feet, and 36 inches is 3 feet. And the students can utilize this when answering the following questions on a worksheet that I provide to them. So they will be asked to measure a pencil in inches, a desk in feet, and the back wall of the classroom in yards. Again, I want the students to become familiar with the different lengths, how spaced out they are, so they become more comfortable with the context of the word problem that I'm going to provide to them. So I'm going to go ahead and go over one of the practice problems that I've provided them. Again, there are a variety of problems I want my students to complete for this unit as they pertain toward mass and volume, meters, and just length in general, as well as measuring in inches and feet. And then, of course, being able to solve using money. Today, we're going to focus on a problem that utilizes the imperial system, specifically converting between inches and feet. So if we look here, we're going to first learn how to decode a word problem. All right, so one way to help a student who has phonemic awareness is to have them read a problem 3 times to help them delve into different aspects of the problem each time they read it. So I'm actually going to have Sarah read this question 4 times. I might have the students work independently in the classroom on this problem so I can independently work with Sarah to see how she does with reading this word problem a couple of times. So again, I would provide a worksheet to the rest of the class to answer the following questions that pertain toward this word problem, but I would have Sarah solely work on this problem with me so I can see how she does reading the problem. So again, we're going to read this 4 times. The first time, the flagpole outside the school is 12 feet tall. The school decided to change to a taller flagpole that is 600 inches tall. How much taller is the new flagpole in inches? What are the key numbers in the problem? Well, I know that the key numbers are 12 and 600. I'll read the problem again. The flagpole outside the school is 12 feet tall. The school decided to change to a taller flagpole that is 600 inches tall. How much taller is the new flagpole in inches? What are the key variables in the problem? So I want you to understand that we have already had a lesson on variables, so the student should understand what I'm asking for. So the variables in this problem are feet, so there's 12 feet, and then the other variable is inches. 600 inches, and we are solving for the new flagpole in inches, or how much taller it is in inches. So I'll read the problem again. The flagpole outside the school is 12 feet tall. The school decided to change to a taller flagpole that is 600 inches tall. How much taller is the new flagpole in inches? What is the question asking us to solve for? This is the last question in the problem, which claims that how much taller is the new flagpole in inches? So we are solving for exactly that. How much taller the new flagpole is in inches from the other flagpole. And I'll read it one last time. The flagpole outside the school is 12 feet tall. The school decided to change to a taller flagpole that is 600 inches tall. How much taller is the new flagpole in inches? What conversion must we make? We need to convert that feet to inches, so that way we can solve the question. All right, so the first thing we're going to do here is convert feet to inches. So I have provided a visual here, and the students have already practiced the concept that 1 foot is 12 inches. All right, so to convert feet to inches, the students must create a proportion. So first they write down the information they are given, which is 12 feet, and they need to solve for inches. So we're going to write X inches. We're then going to write the proportion or the scale that we were provided, which is 1 foot to 12 inches. And we're going to solve by cross multiplying. To cross multiply, we do exactly that. We'll do 12 times 12, which gets you 144, and 1 times x, which gets you x. So our answer here in this case is 144. I will then ask Sarah what the answer to this problem is, including the units, and the answer here is 144 inches. As a way to determine how to set up the equation, we will look further into the arithmetic terminology. Are we adding, subtracting, multiplying, or dividing? The answer here, and again, after delving deeper with Sarah and the rest of the class, we're looking at the word taller. Taller here means that we know that the old flagpole plus a certain amount equals the new flagpole. Once we understand how to apply the arithmetic terminology, we can set up the equation, which is x plus 144 equals 600. I want to emphasize that this is solely a lecture and that I will be providing additional practice to students, specifically Sarah, in specifically how to identify arithmetic terminology as well as how to write and solve equations, but this is solely the lecture. So how to solve this equation? We always want to do the opposite arithmetic symbols. We want to do the opposite of those, my apologies. So if we have x plus 144, we want to do the opposite and subtract 144 from both sides, and we get 456. Finally, I will ask Sarah what her answer represents in the context of this problem. Again, our answer is in inches. However, what does that mean? Specifically in this problem, the new flagpole is 456 inches taller than the other flagpole. Again, thank you for viewing my lecture, and have a good day.